in chemistry, we normally, like I was saying before, measured things, measure temperature using either Celsius or Kelvin scale, right? Units. Fahrenheit's very rarely used in chemistry, but it is still good to know how to convert between the two. So this is just a chart of some interesting conversions between all three. So the equation to um, convert Fahrenheit into Celsius is Fahrenheit equals 1.8 times Celsius plus 32. Okay. Um, I actually learned it as 9/5 here because 9/5 is actually the same thing as 1.8, but in fractions, right? It's the same thing. And the reason why I learned it that way is because when I was taught how to convert Fahrenheit into Celsius, right? When I was taught how to do that, or vice versa, I was taught it using a graph. So if I put Celsius on the x-axis and Fahrenheit on the y-axis, right? And let's say we use body temperature, so 37 degrees Celsius, 98.6 degrees Fahrenheit. 37 degrees goes there, right? And 98.6 degrees goes there, right? That's a point, right? Because those two are equivalent to each other. But then I could go up here to boiling point, which is 100 degrees Celsius. And up here is 212 degrees Fahrenheit, right there. And I can put another point, because those two are equivalent, right? And since those two are equivalent, I can actually draw a line in between. And it turns out that every single spot on this line is a Celsius to Fahrenheit conversion, right? Every point of that line. And it turns out that this 9/5 right here is actually the slope of this line. I don't know why I drew it that way. Forget that part down there at the bottom. All right, is a slope. And in this slope, right, the 9 goes there, and the 5 goes there. Wait a second. That F equals 1.8 times C plus 32 sure does look like something crazy. It actually looks like what we learned earlier, which is the Y equals mx plus b equation of a line, right? Equation of a line. That's this line, right? So check this out, right? That 32 right there is the y-intercept, which means if you extend this line out a little further, right? A little bit further, this line crosses the y-axis at what? 32 degrees Celsius, right? 32 degrees Celsius. So interesting. And what is this right here then? On the 32 degrees Fahrenheit, right? 32 degrees Fahrenheit. This spoke there, right? 32 degrees Fahrenheit. So what is it on the Celsius scale if you went down here? This then is 0, which is the freezing point, right? The freezing point of Celsius. And if you look over here, the freezing point of Fahrenheit is 32 degrees Celsius. And the freezing point, 32 degrees Fahrenheit. I keep on saying Celsius because that's all we use in chemistry. But 32 degrees Fahrenheit. And then we look over here, the freezing point of water in Celsius. I just said it again. 32 degrees Fahrenheit. And then we look over here, the freezing point of water in Celsius is 0 degrees Celsius, right? So you can actually use a graph to do a temperature conversion. Pretty cool. And then it's actually really easy to convert from Kelvin to Celsius, because Kelvin actually just equals the Celsius temperature plus 273. Uh-oh, what happened there? 273. That still looks like 230. There it is, 273. Except you couldn't see it anyway. So let me write this over here. Kelvin equals the Celsius temperature plus 273. And that's how you get the Kelvin temperature.